All right, so we have to start at the reject region. Now remember, guys, this is just another way to test. Reject region is, I like it better. I think it's just more visible. It makes more sense when you look at it, and there's no test to be had. You don't have to worry about the detail. It's the same information. It's just looking at it from a different viewpoint. Again, once you make your decision, it's there on your graph, and then you're still going to interpret major hint. All right, so all the first three wanted you to do was to find the critical value. The book calls it Z sub 0. I happen to call it Z sub C. You can call it whatever you like. Just identify it because it's different than your Z-score for your test statistics. I call it a C for critical value, cutoff value. Once you do this, you should fill in your shaded area with reject HO and fill in your non-shaded area, fail to reject HO. If you want to use the abbreviations fail to reject HO, that's fine. Just make sure you say HO in there. A few years ago, one of my kids put an FTR and went, what the heck is FTR? And I failed to reject. I'm like, ah. So remember the right tail, if you look up inverse norm, you have a couple of ways to do this. If you go to inverse norm, it's one tail, so only divide by 1, which puts you at the same thing. If you leave it like this, you are going to get the negative value because you get area to the left, which is fine. You know it's on the right-hand side, just make it positive. If you want to do inverse norm because area is to the left, and you want to say 1 minus 0.10, then it gives it to you the positive, or 0.05, sorry. 1 minus 0.05, then it gives it to you the positive. But I really don't like having to do that. That's up to you. Because remember, area is always to the left. So when you look it up, it's this area here. You want that little tail right there. Looking it up to the right, when you're looking up a left tail test, is a little bit different. It is already your area to the right. So that one falls exactly that. So you're going to label this guy reject H0, and this fail to reject H0. Everybody good with that, finding the critical values? That's the hardest question. Two-tailed test, remember, you have two things to share. So when you do inverse norm, just say to yourself, what do I divide by? I divide by 2 parts. I have 2 things in here, so I'm 0.01 divided by 2. Let the calculator take care of this. And then there's your 2 pieces. It was 0.02, sorry. I put in 0.01. So there, you get your negative, and you know the other side, the right side, is the positive side. And again, we label this reject H0. And fail to reject H0. Good. Now we're going to work with your Z-scores, and when we find your Z to test statistic, we're going to see where it falls into your graph. And that's your decision right away. So these guys, these are their reject regions. This is their fail to reject region. Of a Z-score of 1.98 falls to the right, so it falls in your shaded area. You can see how small that area is. We don't want to allow anything that's that small or smaller. That's what we test for, because that's very unusual. A -2, +2, -3, +3, they're very unusual. So we want to reject HO when that happens. -1.89, it falls right before this, somewhere over here. -1.89. 1.65, somewhere here. These are our decisions right on our chart. -1.99, right in the blue, right in the reject area. So we say reject H0, fail to reject. That's our decision. We don't have to compare anything else. From there, we go to the chart and we say what we came up with. All right, so now, a company that makes Coca-Cola drinks states that the mean caffeine content is 40 milligrams. So is 40 milligrams, that's your claim. You identify that as your HO. Your HA is the not equal to. Remember, the not equal to has an open circle and two arrows going out on your number line. So that's where your two tails come from. So it has two tails. Find your critical values. Label your graph first. So this should say reject H0. And this should say fail to reject H0. Okay. Find your critical value. This has two tails. Divide it by 2. Just put it in your calc and let your calc do it. So you have a negative 5.75, or if you give me 5.78, that's fine. 2.58, that's fine. Just make sure your rounding is correct. If you use the calculator, we'll put this in the calculator after this. Calculator will come out a little bit differently because of our rounding. Once you get your thing set up, then take out your test information. Your test, you find a random sample of 20, not 12. 20, 12 ounce bottles. That your sample has a mean of 39.2. And it has a population standard deviation of 7.5. So you want to test this. Use your z-square formula and find your test. This is called a test statistic. You want to see where this falls. This falls right in here. Call it the ZT, the z-test. It falls right in there. So this is our decision. Automatically, we see, fail to reject H0. Now, if you fail to reject H0, does that mean you go along with it? And if you fail to reject it, yeah, we're going to go along with it. So we follow our chart. Our claim is H0. We fail to reject H0. We have to say this. There is not enough evidence at a level of significance of 0.01 to reject the claim that the mean caffeine content is 40 milligrams. You've got to say that. You know on the test that's going to be there. That's your culmination of this whole thing. And you could take months to test this. You challenge somebody's statement, you could take months, years to test this. Absolutely not years. By the time you come up with a good sample, your sample has to be a good representation of your population. That's why if our samples come out too small, too extreme, we don't want them. Everybody do this? Olivia, does it make sense to you? Any questions? No? Okay. The light bulb manufacturer guarantees that the mean life of a light bulb is at least think money in your pocket. You have at least $750, you have that or more. So greater than or equal to. That's the HO. The HO always has the equal sign. The HA is the less than. So the graph is going to go by your less than. So we fill in our graph. We say, okay, there's my reject. There's my fail to reject. I look up my z-score for this guy. I only have 1, so divide by 1. And this is my cutoff, my critical value. I pull out my test information. I'm testing 25 of them. They told me my population is normally distributed. I find my z-score and I see it falls in my fail to reject HO. This is my decision. My claim again is my HO. Again, you fail to reject it, so there's not enough evidence to reject this claim at a level of significance of 0.02 that mean life of a certain light bulb is at least 750 hours. I'm the manufacturer. Of course I'm going to say at least.
go to your table and get that value for C, or C, I mean,
To this,
for Z, like I got to negative 0.42, what was the value of that in the table?
that I don't care, because that's my p-val test. But, what is the value of that from your table?
I got 0.6628.
Yeah, no, it can't be.
I don't know.
0.6628, it's in the negatives. It's got to be less than 50%. Go to your table 4 and look it up again and tell me what it is. Do you have a table on you? Does anybody have a table? We'll make it quick. Riley has her table right at her fingertips. Because I'll show you where this fits in, John. Negative 0.42. 3372. Thank you. Do you find it? Okay. 0.3372. What do you do with this?
Mm-hmm. Once you compare it to the inverse norm thing?
You compare it to the p-val that you originally looked up. So this is your p-val for this thing. You compare it to your level of significance, which is 0.02. And don't we say that's greater?
Yeah.
So this test that we did, we bypassed the p-val. Instead, we used the z-scores. The z-score associated with this guy was negative 0.42. The z-score associated with this guy was negative 2.05. We saw on our graph the same information. This is the same exact information, just a different way to look at it. In the one time when we test p-vals, we just look at the value under the curve. And the level of significance is a value under the curve. When we do reject region, we say, give me the test z-score and compare it to the z-score associated with that area under the curve.
So where did you get the negative 2.05?
I don't need this at all. This negative 2.5 came from this area right here is 0.02. So that's where I went to my calculator and I said inverse norm. Give me the z-score associated with this, because now I want to test z-scores.
Okay.
So at one point we're testing areas, in the reject regions we're testing z-scores. It's still the same information, just a different view of it. Okay. So still getting a different view. And this is when we test p-val. It's going to give you the same result. This is when we test z-scores. And the last one that you guys had, was this it? Did you have this? Okay. A fluorescent lamp manufacturer guarantees that the mean life is at least, again, greater than or equal to 10,000 hours. And that's our HO because it has the equal. Our HA has the tail in it. So we're kind of testing. Our HA is going to be the opposite of what they're saying, isn't it? A manufacturer, of course, is going to say greater than or more than or equal to. We're saying, hey, I didn't get 10,000 hours out of this. I'm saying it's less than. So now, our level of significance is 0.09. What is the z-score associated with 0.09? Because this is going to be where I reject HO. This is going to be where I fail to reject HO. And if you just think about it for a second, it makes sense. If the opposite of this is saying it's less than, if it falls in here, wouldn't you reject HO? Doesn't that make sense? If it doesn't fall in here, it falls where he says it's good, then I'm okay with it. I fail to reject HO. So these do make sense if you think about them a little bit. So I find the cutoff through inverse norm. There's only one tail. I use my test statistic. And again, I find it slightly to the right of that number. So therefore, my decision, that's reject H0. And again, there is not enough evidence at this level of significance to reject the claim that the life of the lamp is at least 10,000 hours. Okay. But it does make sense if you think about it. My opposite, my counter one for this, my counter hypothesis, falls in here. So I'm testing this part. If I find that it is too small, then I'm going to fail to reject what he's saying. If I found it is less than this. The only bad part is we have to go through all of this to show how we do it. Right? We have to go to our chart, get the words for it. We can't just say I agree or don't agree. We can't say it's good, it's bad. We have to either have enough evidence to reject it, have not enough evidence, insufficient evidence to reject it. If it's an H8 claim, we use the word support. And that's nice too, because when you get down to here, you have enough evidence to reject the manufacturer's claim. Right away that tells me HO. If I didn't set my claim up as HO, something's wrong. Okay? And again, p-value test. We took this p-val, 0.09. That's my level of significance. And we would test it to this p-val for that test statistic. You would pull out that area under your curve and then test it against this, and you still would see that that was greater than that. That's the p-val side of it. We're either going to do the z-score side of it or the p-val side of it. Do you guys have a preference? Which one you like better?